Okay, so here's a Bernoulli effect problem. Every few years, wind in Boulder, Colorado attains sustained speeds of 45 meters per second, about 100 miles per hour. When the jet stream descends during early spring, approximately what force due to Bernoulli's equation on a roof having an area of 220 meters square? The density of air in Boulder is 1.14 kg per meter cube, and the atmospheric pressure is that. All right, let's do a diagram. So here's the house, and the area of this roof is 220 meters square, and the winds are blowing at we'll call it V1, and inside V2 is 0, 45 meters per second. Okay, so what Mr. Bernoulli says is the pressure at location, this is location 1 and this is location 2. Pressure at location 1 plus 1/2 rho V1 square plus rho GY1 equal to pressure at location 2 1/2 plus 1/2 rho V2 square plus rho GY2. Alright, so what we are doing is the thickness of the roof is negligible compared to the height of the roof. So we'll say y1 is equal to y2. And so both these terms drop out. Okay. The pressure at location 2, and now V2 is 0, so this term is 0. And the pressure at P2 is atmospheric pressure, which is that. Okay. So what is it? What is the force? So what is the force? So you can see from this equation that since P1 plus this term is equal to P2, P1 is much lower than that. Okay, so the force on the roof is in that direction, and that's equal to P2 minus P1 times the area of the roof. Okay. So I'll draw the house as well. Okay, so let's do that. The net force on the house is P2 minus P1 times the area, and from this equation here we can see that P2 minus P1 is 1/2 rho V1 squared. So that's equal to 1/2 rho V1 squared times the area. All right, let's put in the numbers. The density in Boulder is 1.14 kg meter cube. This is 45 meters per second square, and the area of the roof is 220 meters square. Is that right? Yep. Okay. And so this works out too. $253,935 newtons. Okay, so that's the Bernoulli force. And now let's get a sense for this. So force is mg. So m is this number divided by 10. So roughly m is roughly 25,000 kgs, and that's about 3 school buses. So that's what's happened. 3 school buses are parked on this roof. Okay. Well, except that the force is upward. and if the roof is not tied down well, it will blow away. All right, that finishes this problem.